Welcome to the experimental whiteboard session. This is a pretty relaxed session. We did this last time we had the fabric workshop in the spring, and it was pretty successful. We hope it's successful again, but the way this is going to work is various people that have projects that they want and experiments that they want to perform on Fabric that maybe they think they know what they're doing, maybe they don't think they know what they're doing, maybe they just have an idea and they want help designing an experiment, are going to come up on stage and they're going to talk to us, present, hopefully if you have like a slide deck or something where you can show us the experiment in a graphic or something, that would be nice. Explain to us what they're trying to do, and we will talk with them and amongst ourselves to help give some ideas about how to best design that experiment. And hopefully things will come out, like maybe there's features of Fabric that the experimenter is not aware of, or maybe there's features of Fabric that we weren't planning on implementing, but if enough users want them, we can do that. And also a lot of times I think that we're going to find users that were trying to use Fabric to do an experiment, but it's really going to be better if we compose a bunch of several different test beds together to support that experiment. So that's the point of the session. I think we only have one, maybe another one of people who have pre-signed up to volunteer for this. So if you're in the audience and you have an experiment that you're thinking about doing, even if it's just an idea for an experiment, I don't know, somehow we can tell Brittany, say something in the chat, and Brittany can start talking to you, and we can get you on the list, and we can pull you up on stage, and we can talk about your experiment after we do this first one. So we have on the stage right now Ganesh Sankaran I think from Argonne, right? I know Joaquin's from Argonne. I think you're from Argonne as well.
I'm from ISI.
Oh, from ISI. Okay, so your partner, who I thought was going to be on here, is from Argonne, and I know him very well, but I wasn't sure where you were from. So you have a project you want to do. It's related to DNS. I think I heard you had a couple slides that you can share to kind of show us what your plans are, and we will just
sure
get our reaction. So tell us what you want to do.
Yeah. Can I share my?
Yeah, I think so.
Yeah. Okay. Can you see this?
I do know. Oh, now I do. Okay. Yes, I see it.
Oh, okay. So generally, in-network computing is one of the hot research areas where programmable data planes, plane switches, are actually used for doing much more than basic packet forwarding and routing. So there are a few low-hanging advantages there with respect to throughput as well as latency. Programmable data planes actually outperform the typical compute systems, and they can actually process billions of packets per second, which is clearly there is a gap between what programmable data planes can do and what general purpose compute devices can do. So there are a few advantages there, and our key question here is can we save power, or rather to put it how much is going to be the power consumption if we actually implement a couple of computing tasks on programmable data planes. So from that perspective, I'm actually working closely with Joaquin at University of Chicago and ANL, and this is actually closely aligned with in-network computing, though it takes a little bit of digression, and then it is trying to implement the entire logic on the compute, trying to visualize the programmable data plane itself as a compute platform, which is something of a little bit of a shift. And our high-level overview of the experiment that we are planning to do is we are starting with DNS as one of the distributed applications. It's a perfect example where you have a lot of cache and you have entry popularity, closeness, and a lot of other dimensions which are actually making it kind of an ideal application to test and then measure the power consumption across the programmable data plane switches. So why Fabric is important? Obviously, Fabric provides a lot of resources that are actually what we want for conducting the experiment, like P4-enabled programmable switches and a nationwide network where we can experiment at scale. We are actually trying to host trillions of entries. Maybe that is the scale at which DNS is there today, but we want to at least try something at a very reasonable scale, like millions of entries or tens of millions of entries. So that's the kind of thing that we are planning to do here. So from an experimental topology perspective, please feel free to actually stop me if you have any questions in between. I'll be very happy to take that. Or if you have a comment, please feel free to interrupt me. So on the left-hand side, we have the current state-of-the-art DNS architecture, where the users reach out to front-tier DNS servers, and they actually cache the popular entries. If there is a popular entry that is found within the tier, it is going to respond back to the users. If it is not found, then it is going to redirect the request to a specific backend tier. This is more or less like a message routing, so which ideally fits the network when it is programmable, as we see on the right-hand side. So we are actually planning to do a couple of phases of experiments. In the first phase, we are planning to observe the front tier, where some of the popular entries will be hosted on the P4 switches, and it will redirect to the back tier. And in the second phase, we are actually trying to observe a portion of the back tier as well, and then try to see what is the scale that it provides. Of course, this is actually like kind of a stretch. We know that the number of DNS entries, the namespace is too huge compared to what we have today. What we can support with the programmable data plane switches today, but we want to actually kind of try and see how it performs with respect to power. And for that, at-scale experiment is very much required. Otherwise, we will not know what kind of what is the dynamic power consumption with respect to if we load it fully, kind of. So that's the thing that we want to actually check it out in this particular experiment. Giving a little bit of description on the experiment, the hypothesis is apart from higher throughput and lower latency, we expect power savings when computing on the programmable data plane. So one of the things that we see here is the static power consumption of most of the devices is 70% to 80%, and the dynamic power consumption is a small 20%, where we can actually play around with. Given that the switches are already consuming 80% of their power, even if there is no load, we expect some kind of power savings here. So in terms of broader impact, we have just taken DNS as one of the examples. We could actually dig deeper, and then we can apply it to many other applications, and then see if they can actually benefit from the programmable data plane as a compute platform as such. So the configuration that we kind of expect is generate billions of packets. Here we have 5 billion as one of the targets. And with respect to the front tier and the back tier, we are actually trying to still have some DNS cache servers, and then compare that head on with when it is actually some of these entries are migrated onto the P4 programmable data plane switches. So we are also looking at, like I showed you in the topology, we are expecting to leverage the programmable data plane switches connected to each other. and then collectively responding to the DNS queries. So we expect to measure power. That's one of the things that keeps coming up. And we should be able to actually measure power from the switches and collectively from the network when trying to respond to the DNS queries. So what kind of requirements that we have is like we require a network of P4 switches, typically like the Trophinos or the Mellanox Spectrum, or recently like the NVIDIA Spectrum or the like. And we are trying to actually see whether a single level tree topology or a two-level tree topology is what we are starting with, and trying to see how much of fan out is going to help us and how much of depth is going to help us. So that's the reason behind trying out with single level and multi-level tree topologies. So we would require like 5 to 7 P4 switches for creating a tree kind of topology. And with each of the leaf switches, we are planning to attach at least 2 servers so that there is some amount of fan out there. So this is the minimal experimental setup. If we have something more, then we can actually scale it up, and then we can plan more. And the ability to measure power consumption, I'm really not sure whether Fabric currently provides this capability. So that's one of the things that we need to see. And ability to modify the network topology. So we may have like 7 switches. We may want to convert it into a high fan out single tree kind of topology, or low fan out multi-tree kind of topology between them. So that's the kind of network topology morphing kind of capability that we require. So that's pretty much what I had. I'm open to questions and comments. Thank you so much for providing this opportunity.
So what I'm hearing, and I'm trying to like just repeat it, and maybe everyone else can correct me if I'm wrong, or correct me when I'm wrong. That what you want to do is you're going to take P4 switches. The DNS application is just sort of separate. You're just going to say like what, like if say for DNS, you're trying to figure out how much power the switches are using, or the switches and routers probably too, are using in the face of some application. And this is spread out all across Fabric, right?
Oh, actually, we will be implementing a portion of DNS responder within these switches.
Okay, so so you're going to implement in P4. You can implement your own DNS or
exactly,
and then the idea is try to like tweak the way DNS is working to try to optimize for power and probably
exactly like
Okay, so one question I have for Ilya, I'm not 100% sure. Are we going to have power monitoring on the actual Toffinos?
So we have some power monitoring capabilities within PDUs.
Yeah.
I do not know enough about the switches that we are planning to have to know whether they have internal power measurement capabilities or not. That's I think that would be an open question.
Okay. And the other part to that is like if we do the sort of Xilinx-based P4 solution, is there a way to get the power consumption of just the one card?
Again, I think it's an open question. I have to look. The servers do have the ability to measure power draw of individual components, but it would need to be verified.
Yeah, so I guess we would have to do that, and we'd have to like enable the measurement system to like measure it, which we would do if it was available. So that's interesting.
One question I had is, do you feel like you're at the stage where you have an implementation ready to deploy on a Tofino switch, for example? Or is it at the stage where you might be able to build out the design on the behavioral model and take advantage of seeing how the experiment might scale out using that approach as a first step?
Actually, that is a very good question. So we have tried with the behavioral model, and in a small scale, we were able to actually respond to the DNS queries from within the behavioral model. So we have that kind of an implementation. But however, as you know, behavioral model does not actually give the performance related attributes, like example, power, throughput, or latency. We can't measure using the behavioral model. So we are looking at the actual devices and at scale kind of measurement, so that it is useful for somebody who is actually bringing their application and then trying to put that on top of programmable database.
Yeah, makes perfect sense. And I guess one sort of general comment I had about this is, how do you evaluate the effectiveness of this? When you're looking at power, is it also measured against sort of the response time you'd expect for queries? So compared to how many DNS servers you might deploy on standard, server hardware versus in the P4 implementation. So how would you compare the two sort of metrics that you're looking at?
Okay, that's a very good question. So at the moment, what we were planning to do is like create the entire topology with the DNS responders outside of the network, which is like the servers hosting the DNS responders, which is the current implementation, and then measure that as the baseline power, and then move towards something like a programmable data plane where the switches host some part of the DNS response system. So this comparison is what we were thinking about. Like you said, definitely latency and throughput will be are easy to measure. Okay. Like end to end, we can measure that. Like we can generate the DNS request and then measure the time when we actually get the response, and that will give us the latency. So we definitely can measure that.
Okay. Yeah, I was just thinking it might require a lot more servers than 8 if the implementation is as robust as it might be in terms of providing a very quick response to DNS queries. You might need to scale up beyond just an initial 8 to do a fair comparison, right?
Yeah.
How that gets deployed and scaled would be an interesting thing.
True. Yeah, but we have actually outlined only the minimal requirements here. So definitely, if we have a larger scale network, we can leverage that. Yeah.
I'd even go further in saying that probably this is like in the category of a type of experiment that extending it beyond Fabric probably makes a lot of sense. So like doing things, for example, I know you guys work on with Chameleon a bunch, or some anyway, and having like, kind of just what Ezra was saying, like having like a larger sort of data center that you stand up on top of like Chameleon or Cloud Lab or some other resource, and have those resources provide like a lot more queries, so you can scale it to like real world situations.
Definitely, yeah. We are looking forward to that, and Walk-in is already having a lot of experience with the Chameleon aspect. So,
do you know? I know there's a couple different groups that have CC Star awards to work with Fabric and do their own research, but like kind of work with Fabric that involve generating traffic, like realistic traffic for experimenters. And there's I think Jack Brassel has one, and then Denise Gerken in University of Houston has another one, and they haven't really started, but they're going to use Fabric and deploy things on Fabric and probably make their tools available to other people on Fabric. I think that's kind of the idea. But that would be generating traffic. I wonder if you have some similar idea about like DNS specific traffic and DNS queries, and is there some tool set or some other project that has realistic DNS queries that you could then generate?
Yeah, that's a very useful feedback. So we haven't actually thought too much about the traffic generation part as is. We were thinking that we would write some socket level programs, but this is a very good feedback.
Yeah, because I could see actually if you did either create something like this, or if you found one. This seems like something that maybe is out there. I'm not sure. I haven't looked at it.
Yeah.
But if there was something that was out there that we were unaware of, it would be really nice if you helped us make that available to all other users, so it's easy to invoke. Make it easier on yourself, but easy for other users that might want to use it too.
Sure.
Yeah. Any other thoughts? I think this is interesting because the takeaway for us is I think we're going to have to. This is really good that you told us this, because some of these power, you're wanting to measure power in very specific spots, and I think part of what the Fabric team that's working on measurements, what they're doing right now is sort of wading through all the possible measurements that users might want and figure out which ones they actually want. Because if you just say, hey, what kind of measurements do you want? The typical answer is all of them, right? But you're asking for something very specific. So it's just something that we'll have to figure out how to make available. I think Jack, okay, this is the same question on both things. Jack has a question, or maybe it's just a statement. So Jack asked, to the extent that switches expose configuration, operations information, possibly power consumption, temperature, GNOE and I don't know, GNOI and GNMI interfaces provide ONF stratum could be useful. Okay, so that's something to look into. I don't know. So this is, I think, probably a P4 interface. Oops, something just went away. A P4 interface that, based on ONF, that could maybe give you power consumption information from a P4 switch. Does that seem right, Jack? I think I'm interpreting that correctly. I'm going to write that down. Somebody needs to write that down for this session. I'll look into that, what that is.
That's a very interesting input. Thanks, Jack.
Yeah. And probably that'll open up a huge door of things that Jim Griffin and his team are going to have to look into to make available for monitoring as well. Do anybody have any other thoughts? Or no?
I think this is sort of gets added to the list of things we need to look at when our P4 switches start arriving.
Yeah, I think that's the I think maybe unfortunately for you in this case, this is probably more of a, you brought up a bunch of things that we haven't thought about that we're going to have to go implement before you can do terribly much. I hope you have a smaller version of your project that you can deploy before you get all of these features that we don't yet have available.
Sure.
Yeah. Awesome. I don't know how we want to do this. I don't think, do we have another, do you have any more questions for us, specific questions? Like if there's specific things that we will make available? I think the topology you have seems reasonable. We'll have enough of those sites available probably by spring for sure. I don't know if we're not going to have we do have plans for Tofino switches soon, right, Ilya? But it's
soon with COVID delays, right? We just ordered them. We ordered 4. April is the target date for when they're going to arrive to us. Then so installation would be within a couple of months of that at individual sites.
And then we also have to work on a way for you to use a Tofino switch, because it's not.
We'll be doing that in the interim. Yeah. We're getting a loaner.
Mm-hmm.
So by then, I hope we actually are ready to actually start, provisioning and making them available.
I think we should think about, for this particular case, how to deploy something in the meantime that is smaller, but gets you to work through a lot of the hurdles you're going to have just working with Fabric in the first place, and you'll come across a bunch of probably just straight bugs, but also just like features that we didn't quite implement the way you need them to be implemented. So it would be good to get you started doing something. I hope that's a good thing.
That's one of the reasons I think I mentioned if it works on the behavioral model, that might be a good first step or foray into working on Fabric is just getting it deployed there and see if it meets expectations before moving on to the hardware-based solution.
Yeah, we can. And I assume you were here yesterday during my demo. We do have the beginnings of a system that should allow people to easily deploy the behavior model in software and do something that looks like P4. Probably going to look for people in the near future to like start playing with that to harden it up a little bit and figure out the best ways to make that available to regular users. So if you're interested in doing that, then I'm open to letting you try.
Sure.
Don't know if we have too much more. I think there's a lot more questions for us and thoughts for us. I don't want to cut you short, but I also don't know that we had anyone else volunteer unless Brittany knows of somebody.
We can summarize, I guess, what we think is here, right? So one is the ability to create a slice that spans a large geographic extent. You want a kind of a tree-like topology of P4 devices. You want some leaf nodes to provide the load. You want to be able to measure power consumption. And you want the ability to modify. So that's an interesting question. You want ability to modify the network topology. Is this, you want to modify, is this from experiment to experiment or within an experiment?
This is within the experiment. We want to try different fan outs.
Well, to me, these are, each fan out could be a separate experiment, but.
Okay, yeah.
But if you're actually looking to essentially break links that are live and then build new links, that's still within an experiment. We are planning to have that capability, but I just want to be clear. For you, what it sounds like is you want to define a topology, instantiate it, test it, define a new topology, instantiate it, test it, like that. Is that right?
Yeah.
Okay.
Yeah, you are right.
Yeah, so modify is on the short list of things that we're planning to add for right now. But right now, what we have is static topologies. You create them, you delete them. Okay, so it sounds like the power measurement is sort of the biggest homework assignment for us. It's figuring out what we can do to measure the power. Everything else seems like it's either already doable or at least enough on the roadmap that there isn't a whole lot of doubt that it's going to be available.
Yeah, so
it's a very interesting experiment, and I hope we can. We'll work towards making sure that you can execute it.
Thank you so much.
Yeah. Well, I don't know how to go to the next phase. Is there anyone in the audience that wants to come up and just share what your thoughts are about how you want to use Fabric and get our feedback about what's that? Oh, Freda Fund would like to. Freda actually has a very interesting, some topics.
Yeah, I'll stop my presentation.
Oh,
thank you.
Thank you, Ganesh. I'm sure we will hear back from you. Or you'll hear from us, and we'll hear from you very shortly. As the number of nodes grow, we plan on incorporating more people or more teams. Ooh, now we have another question. Ooh, a place where programmable backplanes may also save power is in active multicast programming? ?
Yeah, definitely. Yeah. A lot of applications out there. Yeah, definitely multicast is a good example. Yeah. Thank you.
Oh, thank you, Ganesh. I don't know how to organize this in a way that I can see everyone. So Freda, who is from NYU and has some really cool projects with, especially with like teaching high school students and undergrads. But I forget the program you participate in, where you have high school students do actual research projects and do presentations. It's great. I hope that's what you're asking about. But if you have other things, let us know.
Thanks. That is a really great program, but that's, kind of more in line with just, standard research use.
Yeah.
I was interested specifically in asking about, what are the plans for educational use of Fabric, like lab assignments and conventional classes?
Do we have anything specific to say about that, Ilya? I think we want that to happen. I think if you saw the P4 demonstration I did yesterday, I truly hope that somebody is interested in helping me turn that into the behavior model tutorial session that can be used in classrooms everywhere. Like we can make some learning modules.
I actually missed yesterday. I was teaching all day. So yeah, that happened. But I'll definitely watch the video later. But I was thinking more, I could definitely imagine using like a P4 tutorial in some of the more advanced classes here at NYU. That would be very valuable, especially because that's like an expertise we're very interested in developing in our students, who then we can, hire as research assistants and so on. But I was thinking more along the lines of, conventional networking classes. So I am an extremely heavy user of Genie for our undergraduate and graduate networking courses at NYU. I think this semester we have approximately 300 students in ECE doing a weekly lab assignment on Genie. And these are, not really advanced stuff. This is an intro networking class, like one of the first classes that many students might take in a master's at NYU, for example. And it typically works, like you SSH into nodes in your experiment and you run commands and you see what's going on and you configure networks and so on. So I'm just curious to hear more about is Fabric expecting to support that kind of use? Is it looking for more kind of specialized use? What's the roadmap here?
I think we want both. I think maybe the right way to say this is I can't think of anything that Genie could do that Fabric couldn't also do. Is that a fair way to say it, Ilya? But then there's like a ton more that Fabric can do. So I think that anything that you have already working on Genie, there should be a way to port that to Fabric, and potentially even have it run better, or have like more like. One of the things we'll have is guaranteed quality of services on links and stuff, which you didn't really get in Genie, and a little bit more isolated in performance isolation about how the VMs stay separated, and like when you get a PCI device, it's fully allocated to you and your experiment and things like that. Another thing that I think will be really valuable to teaching, especially when you get like a huge classroom, you said like 300 students, you can imagine like even just a few dozen students trying to use these services at the same time, they kind of get in each other's way and that kind of thing. So one interesting thing that we're doing on Fabric is there's different types of networks that you'll have available to you. So there's like what you're familiar with in Genie, which is you get your layer 2 circuits, which is great. There's also going to be an IPv4 network that just spans all of Fabric on its own. So you can create nodes within Fabric that are connected to each other over an IPv4 internet that is isolated from the real internet, but can span all of Fabric. There's also going to be an IPv6 network that works this way. And the IPv6 network will actually peer with the real IPv6 version of the internet. We will, like Fabric itself is an IPv6 AS, so we'll be able to do things like that. The other interesting thing is that even with the layer 2 circuits, you'll be able to choose between if you want dedicated quality of service. Like if you want to have 100 gigabit per second link or 10 gigabit per second link, you can do that. But if that's not what you're into and you just would rather support 300 students at the same time, there's going to be a corner of it that is best effort, but layer 2 links using VLANs. So you can kind of like choose how that works. I mean, obviously 300 students can't each have a 100 gig link at the same time, at least across the wide area. I don't know what else to add about that.
I think what you said is accurate. So we actually had a number of discussions about supporting education use cases, and specifically, we were talking about scale, right? That's going to be a big challenge. Fabric is definitely more capable than Genie in many dimensions. But I think one thing it doesn't have in its current plan is the size, right? The number of sites is smaller. The sites themselves are, reasonable, but not huge. So we'll have to see how we can scale up. We've discussed things like, hey, can we have like these super small, non-guaranteed virtual machines? Not non-bound to a CPU essentially, that we can just stand up a bunch of them. Because right now, as per what Paul was saying, we've actually added this feature specifically for scalability, these shared interfaces, right? Because we can have, I think right now we've defined up to like 120 per worker node. We can have more. This was just the limit that we thought was reasonable. So, as a result, each site can serve, 380 some connections, individual connections, right? And that doesn't matter what service you attach it to, layer 2 service or a layer 3 service. I think so the big question is going to be, technically we're preparing for serving educational use cases. We definitely recognize that importance. The question is going to be scaling, and the question is also going to be in the what the policy is for accepting users into Fabric, because our initial because we're not in operations right now, right? We basically it's essentially invitation only. But there will come a time when we approach operations where we're going to start shifting to a more open mode of operations, and what that looks like actually still requires, I think, some discussions with NSF. From our perspective, we have not had those. I can tell you that I think my personal preference is that we have essentially a quote unquote free tier, where you don't have to do a lot of work to sign up for that, and you get some basic resources like virtual machines. You get shared interfaces. You don't get GPUs, you don't get NVMe drives, you don't get FPGAs. If you want your project to be upgraded to that, there is a process by which the decision is made that yes, this project should or should not be allowed, because those are sparser resources, much sparser resources.
So you'd essentially have like a free tier that's kind of like, what Instagenie currently is.
Kind of like, yeah, I think that's sort of the idea. Now, again, my opinion, right, not the policy. I think that's something that's going to crystallize, needs to crystallize fairly soon, within the next maybe year to 16 months or so, as we start approaching the end of the construction phase and start thinking about operations. So,
and keep in mind, it's all free. It's just a matter of like,
yeah, it's all free. It's more like how much friction there is to actually get to the next level, right?
I mean, when we're talking about like 300 students, even like a tiny bit of friction becomes a huge headache.
Right, understood, exactly. Right. So,
and Freda, I wanted to ask if there are any particular sort of stumbling blocks for your students that you might want to relate. I know that when even I had small classes of 30 or 40 students, some of the common issues were them all picking the same aggregate manager, for example, in Genie, and causing issues with complex topologies, or non-deterministic interface naming on virtual machines really threw a lot of students for loops, right? So I was wondering if there are anything that we should be aware of that, in your experience, has been a problem that would be nice to address within Fabric.
Well, definitely the Genie operations team in the audience can comment on some of the issues we faced along those lines. Yeah, so definitely, resources and scaling is always an issue. Obviously, having this monitor, this like fed for fire monitor of Instagenie is very helpful because, from day one, I direct students to that and I say, pick a site with many free VMs. And the more prominent that kind of visibility is, the better. So I'll give you kind of a very practical example. On this fed for fire monitor, you're familiar with the interface I'm talking about? Yeah, so it lists these Instagenie sites. And for each one, kind of on the main page, it lists the number of free VMs out of total, and it also lists the number of free IPv4 addresses out of total. So it's kind of a straightforward interface. You can look at it and see which sites have many free VMs. But anytime you introduce even a straightforward thing to 300 students, it gets a little tricky. So one example of that is the order of those displays is not the same. So some sites have free VMs and then free IPv4s, and some have the reverse. So students don't always know how to read those. Also, some sites seem to report like the total number that, you know, as a denominator in the fraction kind of goes down as a load increases, and some don't. So what happens is you'll have a site that has like 100 out of 250 free, and that's shown as like yellow because it's half loaded. And then you'll have a site where the denominator somehow goes down as it's loaded. So then it will say like 22 out of 25 free, and it's green as if it's unloaded. So students will prefer the one that has, you know, 20 out of 25 free, even though it's much more loaded. Yeah. So even very small interface details like that, you know, you can expect researchers to deal with when you have a class of 100 students and it's their first class at NYU and they've never used anything like it before. It's even something like that makes things pretty difficult. And then, yeah.
We may be a little bit ahead of you on this one, because this is already available.
Right. So I've seen this.
Yeah.
I suspect that my students would not know how to read this. I'm sorry. It's just the truth. It's perfectly fine for like, I can read it.
Right.
My students would be like, what am I looking for? Do I need cores? Do I need disk? Do I need RAM? Like, how do I know which side I need?
Sure.
All right.
Well, at least we got the columns consistent and the denominators right.
Yeah.
That's a starting point.
Right. I think the notebook interface that you have in Jupyter is kind of interesting from an education perspective, but in its current iteration, I would never use it. The reason why is because, you know, I'm not teaching programming or anything like that. I just want students to learn how to configure networks and learn what they can expect to observe when they, you know, configure networks in a certain way, observe protocol traffic, and so on. And you know, I don't expect my students to know what configuration steps to take. I give them commands to like copy and paste into their terminal. But I think with the notebook the challenge is they would just, you know, click run, and it's kind of difficult to write the code in the cells in a way that makes it obvious to students what's going on.
There's like to that point, and I think that I agree with that. And I've been trying to do with some of the notebooks as we're moving forward, trying to pull like big utility functions out of the notebooks and put them into like a little library that can either sit like right next to the notebook, or there's even for some things that are really common, we're thinking about, we actually have it, it's just not really deployed very well yet. Something we're calling fabric testbed extensions, which are basically just a bunch of utility functions. That's where there's like some of the students we're working with have developed a GUI, and some other people have other students have developed ways to like embed Grafana inside of the notebooks, so you can kind of have some monitoring stuff embedded in the notebooks, that kind of thing.
That's not really what I would want at all. What I would really like find helpful would be if, you know, there was like a notebook-like interface, but instead of kind of having a lot of like Python code that's a little bit impenetrable to students, if there was like a cell at the beginning that just set up the topology, and then every cell after that was just like, you know, some library function where you call the function and you pass the name of the node and the command you want to run on it, like just like that, and see the output. Like that would be something I would probably use.
I think that we want to build stuff like that. I also think that this might be an opportunity to have other groups like you, in fact, potentially, to build packages of things that can run inside of our Jupyter Hub. We can even, you know, and then you could have kind of whatever you want. And I think that there's an opportunity to have maybe like a focus group that's working on education that builds tools like this, or at least helps us design what you want, and make it easy to design it. Because I think that probably, like if we design something and we say, here is the topology that everyone's always ever going to use, like that's not necessarily going to work for you either, because you want your own topology that teaches whatever you're trying to teach, right? So like we need a way to like allow it to be flexible enough for you to customize it, but then on the front it's easy for the students to use it. So it's going to be somewhere in the middle, I guess. I don't know.
Yeah. So yeah, I'd be interested in working on something like that with you guys.
Yeah.
If I can mention one more detail about Instagenie that my students find endlessly confusing, is that this is like such a small detail, but when you have 300 students, that means like every semester I get like 4 dozen questions about the same thing. So my intro networking class is a bottom-up class. So they, start at essentially layer 2. And when they're at layer 2, we kind of drill into them that if you have hosts on the same network segment, they all see traffic for all other hosts. And then we're like, okay, here's a bridge, okay, or a learning switch. Right? And then after that, we kind of move on from there and go to higher layers. And every time we do a higher layer experiment, I get questions about why these hosts on the same network segment don't see each other's traffic. And that's because on Instagenie, it's kind of like basically impossible unless you're, using like, specifying exact PCs you want your resources to be on. It's really impossible to, reserve resources so that there's not a learning switch separating some of them. So that's just something my students find endlessly confusing. And by resources, I mean VMs. Yeah.
I think that one thing that might be interesting about the way we're doing it in Fabric, I'm trying to think of, like, Ezra might have a little thoughts on the two, but the way the network interfaces work on Fabric is that it's always a raw PCI device, always on the data plane.
Right. Well, now we're talking about like small VMs, though, right? Like
yeah,
that's the eventual goal.
Yeah, but it's always a raw PCI device, but sometimes that's an SROV virtual function.
Okay.
So it should be that always the traffic goes onto the network and does the right thing. Now, I don't know, like Ezra, I should probably know this but I haven't looked into it. When you use NSO on the Cisco switch, that is our data plane switch, is it acting, and it's in a VLAN, is it going to filter based on MACs to hide traffic?
No, it shouldn't. So, so if you create, for instance, our layer 2 bridge service, one of the design principles has been to avoid any kind of local host forwarding between virtual machines. As Paul mentioned, every virtual machine is basically going to get a PCI device, a SRIOV or a dedicated NIC, and we ensure that the forwarding happens at the data plane switch itself, even if you're creating a local area network across virtual machines that are on a single host or spanning multiple hosts at a given site. So in that sense, it should be much more easy for students to reason about what a local broadcast domain looks like without having to think too much about it. And it should be very consistent whenever you configure a local area network using a layer 2 bridge.
And we were even thinking about it maybe like one step further even, is that part of the reason we're doing that. So for example, if you have 2 VMs on the same host and they both have SROV virtual function NICs and they want to talk to each other, even if those SROV virtual functions are on the same physical card, we're going to make the traffic bounce out to the data plane switch and back. And that's
exactly what Genie does not do.
Yeah, and part of the reason is because if you want to run an experiment twice, and like one time your VMs end up on different hosts and one time on the same host, the latencies and bandwidths will be like night and day different if we don't do that. So if you want repeatable experiments, you have to do that, right? So that's kind of what we're doing. Or we have to have a way where you can explicitly ask for one of those 2 scenarios, and you always get that, and we'll never get the other. But instead, we just made it so that you'll never ever shortcut through the NIC. Yeah.
Cool.
So that should help with that problem.
Yeah. I think that was all my 2 cents about education.
No, it's good. We need to be more aware of it, and we will definitely be looking for people to help us build out this, because we only have so many hours in the day.
We're going to have someone, excuse me, we're going to have somebody reach out to you maybe in January to get a little bit more feedback, give it in writing. Okay.
Okay.
Sorry.
And then we have a question. I don't know if it's related to this conversation or not. So from Joe Breen at Utah, 2 teaching and onboarding groups, there will be some prototypes of using experiments across different test beds. Oh, so this is a very interesting question too, related to what Fred is talking about. So yeah, one of the interesting things about Fabric that is going to make teaching with it probably harder is that, you know, so in Genie, the idea was kind of that like a way to see Genie is it was really just more like a distributed cloud. Like it has a whole bunch of edge clouds everywhere, and you can create circuits across the middle. Now with Fabric, the kind of the reasoning behind why we want to build Fabric is we wanted to actually program the middle of Genie, and put, you know, switches and P4 and all these other interesting things in the middle. But at the same time, we didn't necessarily want to require people to use the edge devices that we have. So like one of the main the guiding principles of Fabric is that we don't really have a compute edge. You can do compute in our core machines, but our compute edge is really all the other things out there. So for a lot of people, that might be like some machines that's on your campus that we set up connections to, or some supercomputing center. Or if you don't have access to these, then of course there's Cloud Lab, Chameleon, Powder, AirPaw, Cosmos, all the things that Joe's listing here are other test beds that everybody that has access to Fabric also has access to all of these, I assume, if they ask for it anyway. So going back to teaching and then also doing research in general, this is the whole federation problem, right? So how do we, like, it's gonna be hard enough that we can create some machines on Chameleon with some networks on Fabric connected to some other machines on Cloud Lab or Powder or something like that. That's going to be hard. Now try to teach with that and make it so it's understandable to students, where, you know, you have 3 or 4 different test beds you're using, and okay, federated counts, like we could probably come close to getting federated identity worked out, but the APIs and the interfaces, is it one interface? You have to use all the interfaces. This is going to be very challenging, but there will be examples of it happening. But it'll be interesting to see how we can make it easy for students. I don't know if Fred has any thoughts on that.
Well, I think the issue that this comes out in a number of forms and shapes, this question. That is that there needs to be a dedicated, relatively large, well, it's noticeable number of people who help serve these onboarding processes. And this could be for, you know, regular sort of traditional researchers. This could be for educational purposes, could be for undergrad research, etc. Right? So, you know, NSF has done this for other types of facilities. You know, there was a CI facilitator role that was created specifically to work with advanced scientific CI. This is no different in many ways. So I think this may be for us to argue to NSF that, you know, either CI facilitator role needs to be extended to support test beds, or find some other ways to, you know, explicitly develop and fund these people who can help. You know, they're not exactly operators, right? They have an interface to the operators, but it's broader than that. They may, in fact, know how to use multiple test beds. And the role is in helping, in kind of, you know, doing what we're doing now, you know, discussing difficulties, figuring out which test bed serves best, figuring out how a particular test bed can serve the needs of an experimenter, so that each, you know, so that there isn't like a snowflake kind of each experiment is a snowflake kind of a thing, but some patterns emerge, and it becomes easier to serve different communities in a more scalable fashion, right?
I kind of wonder, it's like back to our, we have this idea, and it's not just our idea, but it's been talked about with Fabric, that what we're going to do is build a test bed of test beds. That's the phrase we're using. And the idea, like the way I've kind of explained it, is that there's 2 different ideas here, 2 different ways to look at it. One is that if you get all the test beds together, then it's just one big test bed, and you can just pull experiments across all of them based on whatever your needs are. And that's super powerful, but also super complicated, right? And then there's another way to look at it, which I think is maybe less known, less thought about, is the idea that you could have a different test bed that doesn't use not federating with Fabric, but is sort of powered by Fabric, right? So like maybe you have, I think the peering testbed example is a good one for this, because they're doing these BGP experiments, and one of the ideas is to allow Fabric circuits to connect different pieces of the peering testbed, and then the users of that testbed may or may not ever know about Fabric. Like the only reason they know about Fabric is because in the corner peering testbed it now says powered by Fabric or something like that. That's it. And I could see that an educational version of this happening, kind of to what Fred is talking about, where you can have experiments where people can deploy little routers and have some really easy way to configure them, and they're just wherever they are, but you don't necessarily know you're using Fabric because your teaching educational testbed is using Fabric and not the individual users. I don't know if that's a good way to look at this or not. Yeah. Powered by Fabric. We need to make a logo for that. We have, somebody said something. Brittany said something. Oh yeah, I should promote this. We have, it's in the chat. Brittany's bringing it up. We have on our webpage something we're calling Testbed of Testbeds, where we have various other testbeds that are partnering with us for all sorts of reasons. And the idea here is that this is a little space. Wow, this is already growing, I think. There's a little space where if you're a testbed owner and you want to promote your testbed or want to attract users or whatever, this is like a place where we can work together and have sort of a I don't know, like a table of contents that lists all the test beds so people can find them. And if you want your test bed to be listed on this page, let us know. Contact us. People are chatting. I'm trying to read it. Electric blanket powered by Fabric is an electric blanket. That works. Do you have any other thoughts? Brittany says there's a form you can fill out if you want your testbed featured. Any other thoughts about education? We do have 25 minutes left, so we can continue to talk about this, or if anybody has an interesting idea.
I think it could, definitely be interesting to be able to incorporate wireless into some of the education experiments I do. Right now in my undergrad classes, which are much smaller, we do that. So we have some experiments on Instagenie and some experiments on wireless testbeds. But I would never attempt that with 300 grad students. So if there's some way Fabric would make that easier, it would definitely be something cool to do.
Mm-hmm.
The idea of testbeds got me thinking about this idea of experiments that are long-lived and persistent that could perhaps provide services to other experimenters, right? Sort of eating your own dog food type of situation. Whether it be some type of experiment that provides some new analysis tool or some experimental software distribution framework. I believe there's interest in having these types of sort of long-lived experiments that could be provided to other members of the Fabric community at some point. I'm curious if there's anyone in the audience who's interested or has thought about that type of experiment that might have a longer duration or provide services that are more generally applicable beyond just a single experimental use case.
Because that is like we'll wait for someone to say something, but that is sort of one of the powers of Fabric that's maybe a step beyond what Genie could provide. Is that one way to think of it is that you can scale things on Fabric. So we have our small links are 100 gigabits, right? That's big, right? And we have lots of locations in the core of the network, and that's a strategic place to be. And I think more importantly, we can connect out to all the other real things. Whatever facility or instrument you want us to connect to, we can work with that facility or instrument and connect it. And what this does is it allows people to have experiments on Fabric where Fabric is sort of the incubator that's incubating like a project that might actually be a bigger project that eventually we need to kick you off and you need to find yourself a new home using Internet 2 or whatever it is. But just purely the success of this project that we're supporting should entice other organizations like Internet 2 to like maybe provide the services, whatever piece of Fabric you're using and is vital to you being able to do your experiment. Then there should be a permanent, long-term, maybe NSF funded place to do that, you know. And right now there just isn't that, and that's why you need Fabric. So
yeah, a proving ground of sorts.
Yeah. But yeah, and we can scale up to, so we could actually support your real users, although we don't want to because we want other people to do experiments too, right? Yeah, that's kind of the idea. Case is saying something about in Amsterdam they have several European and Dutch testbeds having a node in their lab, so Testbed Exchange. So we should have a Testbed Exchange, so a place where all the testbeds. So it's the same as federated testbed. So we should have a place. I mean, kind of you can think of like Fabric is potentially the Testbed Exchange. You can think of it that way. So like if you have a testbed and you connect to Fabric, then now you're connected to all the other testbeds, and you can design the Fabric core of the network in whichever way it makes sense for your testbeds to work together. Does Case want to say? We're going to bring Case up. Case wants to say something about.
Yeah, please, Brittany, could you?
Thank you, Freda. Stick around. You can chime in more if you want. I'm getting too many messages popping up. Oh, there's Case.
Oh yeah, am I there?
Yep.
Wait one moment. I need to. Okay, so get my hair correct. No, I was a bit confused with the different chat sessions where to type something. No, about the testbeds, the slices testbed is becoming active. We are now we are almost beyond the design phase. So that is something where European experimental work, pretty much inspired also by Fabric, will be created in the coming years. The other one is the Dutch testbed 2-stick, where we also want to experiment with SIOM routing protocols. And these kind of protocols you want to test worldwide, not within a testbed, but actually across testbeds, how these protocols would work. And so some of those use cases are being worked out. And that seems to me a good example of what we could try out between testbeds. Another one is 5G experiments and connecting with 5G labs, like in Bristol, but also something like that might be possible with some vendors' 5G labs. I was invited earlier this week to also access a lab in Dallas from some company. So we should think maybe about how to facilitate that. So you can also see all those testbeds as ISPs that come together at some internet exchange. But now the challenge is that we have way more complex resources that we want to share. So the information that we need to pass across the exchange to different testbeds is also more complicated. And that is one subject I have currently an tenure tracker assistant professor working on. Domain-specific languages to describe complex infrastructure and describe complex policies and how to deal and reason with that across domains. So these are just a few ideas I dump into this late night meeting, although for you it is afternoon.
Do you have any federation ideas, Ilya? I know you thought a bunch about this.
Well, so this, yeah, I mean, it's federation sort of is always in the eye of the beholder. We had an earlier discussion today, right, that Tom led. It can take a number of forms, and I think, to me, the biggest thing is what's the, there has to be some initial pull from the experimenter community, right? At least an indication of interest, right? Then, as we've talked about this a number of times, there are ways to do kind of a federation, what I would call federation light, where you essentially do just basic connectivity, whatever form it happens to take. A lot of times it's a layer 2, sometimes it could be layer 3, whatever makes sense. And then essentially, if where it kind of comes together is if you have a place where you can use the tools for both test beds at the same time. And we've been arguing that a Jupyter notebook is a good place kind of to be the apex of that activity, right? You have a notebook that has Fabric tools, you have a notebook that has Chameleon tools, Cloud Lab tools, whatever other tools. Then you can at least, with some friction, right? This is still not frictionless because we haven't talked about identity federation, we haven't talked about API federation, none of that. Just a place where you have the tools for 1 or 2 or more test beds in one place, and maybe a little bit of help with managing, your token, your certificate, whatever happens to get you into the door. Then that would be like the next step in my mind, because that allows you to more precisely judge the actual pull, right? Initially, an experimenter or 2 or 3 need to stand up and say, I really would like to use these test beds together. I mean, we really need to hear that. For us to guess and say, well, wouldn't it be nice if somebody used, this and that test bed? That's just us guessing, right? It's not data. So somebody standing up and saying, I'm really interested, and these are the test beds I'd like to use together. Or these are examples of experiments I'd like to do that one test bed doesn't accommodate. Then we can move on to the next step, right? Because it's an engineering effort to both provide the connectivity as well as make the tools kind of work together somewhat. But it's still not as big as kind of a much broader set of federation activities where you try to unify your identities, where you try to unify your information models, where you try to unify your APIs. Those can follow if you have enough pull indicated in those first kind of 2 groups, right? It's a kind of initial interest and then initial users that just use those initial capabilities, and it gives you an idea that yes, there is interest. Because otherwise, it very easily turns into, if you build it, they will come, but then they don't come.
No, I agree with that. So I also try to indicate that Cyan is such an example that might need this. But to your point, the way you describe it makes it really sound complicated, which it also is. What I would hope is that if you have somehow an exchange, that then you only, from a testbed point of view, agree on an exchange protocol, and whatever implementation the others have, they also only agree with the exchange protocol, and so that you don't have an n-square problem, but at most a 1 or an n problem. But this is something I just put in an ID, but it is something, and I don't expect anything to happen on this tomorrow or in the next half year or the next year, but it is something to think about. How would these, because anything you otherwise invent in one administrative domain, in one setup, in one community, stays otherwise bound to that community. So it is a kind of architectural thinking what I'm trying to do.
Right. Well, so I mean, our experience and observation, at least my experience and observations, are that test beds a lot of times very much are kind of vertical, very vertical, right? Yeah. They're built for a specific purpose, for a specific community. And a building a common, some beginnings of common API. The problem with that, in my mind, is that without concrete use cases, you may end up building something that's not terribly useful, because in trying to make it as simple as possible, you hide too many things, too many of these vertical capabilities that each individual testbed provides. I mean, if you take a testbed that provides like a fixed millimeter wave versus Fabric, which is a WAN testbed, I mean, the intersection is quite small in terms of how they present the capabilities, how they provision the capabilities, right?
Yeah. And similar things we actually experience also in Amdex, in data exchange, where you want policies, law, norms, values, and use of data to be exchanged between different domains. So no, I understand what you mean. It is also actually part of our research agenda. But this is just a long-term shot.
Right. I agree that actually we should be talking about things. We the testbed builders, I guess, should be talking about these things. But in terms of investing large engineering efforts into actually implementing something like this without use cases would be very, very risky, right? This is where we need to this is where the part that I talked about, I think, would help, because then you would have a ready-made core of experimenters who are interested, and then you can test the capabilities and you can say, well, this really does work or this really doesn't.
Yeah, no, I agree. So I'm not requesting resources at this point, so I don't want you guys to drop everything you are doing and do this tomorrow, so don't worry. But yeah, we are actually also working on use cases of connected cars and so on, which is way more in the automotive and so where. But anyway, I just drop it as a thought. Okay, that is probably all I would bring in now.
Cool. Yeah. So we do have 10 minutes left. I guess if somebody had a short 10-minute, I guess if somebody had something we can talk about in less than 10 minutes, we can bring them up as well, or we can go have coffee for 10 minutes. I'm not sure what we want to do. Any opinions, Ilya?
I think we can, if there's no other questions, we can end early and then reconvene for the last session at 3 o'clock.
This is really good. Keep in mind that we probably will do this again at most of our workshops. It might actually go better in person even, but the idea being that we want people to come with experimental ideas or ideas for experiments, and we can help craft them and get you knowing about the features of the testbed that you maybe don't know about, or like features of other testbeds that could help you, that kind of thing. I'm hoping to do that. This was good though, because I think we're early enough in Fabric's existence that I think we're probably learning more than the users are at this point. So I think that's what this session was more about, maybe. Yeah. So unless we have anything else, I guess we could wrap it up. Brittany, do you want to make any announcements or anything before we close this up?
No, just that the next session is at 3 o'clock, so you guys can join then. And as Paul said, grab some coffee, or of course you can go into the lounge and talk with other people there.